Hello class, this is lesson number 2 for the week of April 20th. Today we're going to be talking about exponent properties. Now I want to warn you, this lesson will be a little bit longer than normal. This is normally a lesson that would take 2 days, so just kind of be prepared for that. All right. So it says there are 8 exponent properties that you need to be familiar with. First, let's review an exponent problem. So this right here, 5 to the third power. Okay, so there's several things with this exponent problem that we need to understand. So let's talk about a few things. Okay, let's first figure out what is this 5 called. Well, the 5 is called a base. Okay, we need to make sure that we remember the various parts. This 5 is a base. The 3, the exponent, well, that is the exponent. Now, sometimes we call that the power, sometimes we call it an index. If it is a 2, we would say that it's squared. If it's a 3, we would say that it's cubed. Okay, but this number right here is what represents the exponent. Okay, now we also need to understand what this means. This really means 5 times 5 times 5. Okay, so this means 5 3 times, or multiplied by itself 3 times. And these 5s right here, whenever I write it out like this, these are called factors. Okay, so when I write it out, these are the factors. Now, when we actually do the math, we end up with an answer. And this answer in this particular case is 125. Because 5 times 5 times 5 will give us 125. Okay, now this right here, sometimes we call that just the product because it's an answer to a multiplication problem. Okay, so we call it an answer, product, the answer to a exponent problem, all those different kinds of things. But in essence, we are just multiplying, and it's an answer to a multiply problem called a product. Okay, so we say this is 5 to the third, or 5 as 5 to the third power, or 5 cubed. Okay, so that's basically, in essence, is what this means. Now, what this really is this is part 1, okay, or this is our first exponent property. So when we look at this particular thing right here, and I'm going to send you this whole thing so you could print this out if you wanted to and follow along in your lesson. This will also serve as your notes. Okay, so just kind of understand that. Okay, so this 5 to the third power, if I ask you to write the factors out, that means 5 times 5 times 5, and you can write it with the dots or the X's. And if you see the evaluation, that means give me an answer. And we just figured out what the answer to the last one was, is 125. Okay, now, 4 to the 6th power, and that's how we would say that, 4 to the 6th power, is 4 times 4 times 4 times 4 times 4 times 4, or 4 6 times. Now, this one right here, to evaluate this one is quite different, okay, because I know 5 times 5 times 5, but I don't know what all these 4s is, because this is really 16 times 16 times 16. I don't have that one in my head. So yes, we do get to use calculators, thank goodness. And there's 2 calculators that we have. Okay, now I sent you earlier during this time of sabbatical during the review how you could download on your Chromebook our normal calculator. Okay, so if you didn't get that, go back through our stream and it will give you the instructions on how to download this calculator for your Chromebook. Okay, so if you like to use this calculator, this is the same exact one that we would use in class. You can do this, okay, or you can use the one that I've been using, which is the classcalc.com, okay, classcalc.com, right? And this one works pretty well as well. So you can do either one. Now, if you wanted to do a exponent problem on this one, we know that we would just do 4, the exponent key 6, and hit enter and get an answer. Now, if I wanted to use this calculator, we got to do a little different. This is our exponent key. Okay, so what I would do is I'd type it the same way. It's just this is my caret key. 4 exponent, notice it pops it up just like that. 6 writes it perfect, gives us the same exact answer of 4,096. So it works either way, okay? So 4,096. And you would do the same for all the rest of these. So 7 squared would give you 7 times 7. 2 to the 4th power would give you 2 times 2 times 2 times 2. Okay, and then we would evaluate those. 7 squared would give us 49. 2 times 2 is 4, times 2 is 8, times 2 is, so 2 to the 4th power would give us 16. So as we're working through this lesson today, we need to understand what these properties are. And this one is our first property, a to the nth. So what does that really mean? Well, that means a to the nth is a times itself in number of times. And this is our first property. Okay. But now, what are the other properties? So let's look at them. Okay, there are 8 properties that you need to be familiar with. As you might have guessed, we just discussed the first property, a to the nth. But here's the rest of the properties that I need you to be familiar with. What happens if I have a base to the 0th power, or a base to the first power? Or what if that base is to a negative power? Okay, or what if we have an exponent on the bottom? Okay, what happens there? Okay, property 5. What happens if I have a base to one exponent times the same base to another exponent? And then what if we have that base to an exponent divided by that same base to another exponent? What happens? Or what if I have a base raised to an exponent raised to another exponent? Or what if I have one base raised to an exponent and then a different base raised to the same exponent? What happens with that? So through our lesson today, what we're going to be looking at is what's going on with all these properties. Okay? So the first property that we just talked about is a to the nth means a times itself in number of times. That's one that we're very familiar with. But let's look at another one. What happens if I have 7 to the 0th power? So take your calculator, okay, pause the video, and actually answer each one of these questions. Type in 7 to the 0th power, 3 to the 0th, 529 to the 0th, and what do you notice about it? Pause the video, and then answer each of these questions for me. Okay, so let's find out how you did. Okay, so hopefully you went to either this calculator here, or you went to Class Calc, and you typed in 7 to the 0th power. 7, oops, let me clear this out real quick. What if I did 7, and then I put that to the 0th power? What is my answer? My answer is 1. Interesting. Okay, so this one, and it is just an evaluation, so we're just putting a 1 down. And then if you did 3 to the 0th power, let's do it on this calculator this time. 3, exponent key 0. Maybe it's just the calculator. I still got 1. Okay, so I still got 1. So if you did 529 to the 0th, I bet you got 1. If you did 7,239,067 to the 0th power, you still got 1. So I'm hoping what you found out was that anything to the 0th power is equal to 1. Anything to the 0th power is equal to 1. So keep that in mind. All right. Now, what if we go to the next one? Okay, the next one is, what if I do a power or do a base to the first power? Pause the video, type each of these in, and find out what do you come up with as your answer. Okay, so let's find out what you did. So when you typed in 6 to the first power, I bet you came up with 6. And if you came up with 8 to the first power, you came up with 8. 65 to the first power was 65, and 8,934 to the first power was 8,934. So if we go back to that first one, it says, a to the nth was, take your base and write it down however many times n says, and multiply those together. Well, how many times does it say to write this one down? It says to write it down only 1 time. So that's why anything to the first power is equal to itself. Okay, anything to the first is equal to itself. Right? So now we come to one of the hardest ones, and this is the hardest one to deal with. Okay, so this one is, what happens if my exponent is negative? Okay, that's going to be the tough thing. Okay, so what I'd like for you to do, we're going to do 1 or 2 of these together real quick. Okay, and then I'm going to have you do a few of them on your own. Okay, so if this one right here, I'm going to go to my little calculator right here. This one is the online calculator. And I'm going to do 2 to the negative 4th power. Okay, so 2, exponent key, negative 4. Now, in order to do a negative 4, I got to hit a minus 4. Okay, so your negative key on this calculator is just the minus key. Okay, so kind of understand that. That one's kind of tough to understand. Okay, so 2 to the negative 4th gives me 0.0625. Interesting. So if I wrote that down, 0.0625, okay, in that particular problem. Okay, now if I were to type this problem right here down, 1 divided by 2 to the 4th power, Okay, so if I were to do that one, let me do that real quick. 1 divided by 2 exponent 4. And notice it actually on this calculator types it in exactly as I wrote it on the paper. Okay, 1 over 2 to the 4th power, it gave me the same exact decimal value, 0.065. Okay. Let me go back here, 0.0625. Those two gave me the same thing. So that means that this exponent problem right here and this exponent problem right here are exactly the same. Okay? Those two are the same. So what do you notice is the difference between these two problems? Okay? Well, I'm hoping you notice two things. Okay, one is that this one is not a fraction. This one is. This one has a negative exponent, but this one doesn't. So what we find out with this negative exponent, okay, and I'm going to go ahead and talk about it real quick. Okay, what we talk about is that this negative on the exponent, it actually turns the problem into a fraction. Okay, so what we look at here is this can be written as a fraction by putting it over 1. This negative exponent here flips the whole problem, that 2 to the 4th, flips it to the other fraction part. This one right now is in the numerator, so this negative flips it to the denominator. Okay? So what I'd like for you to do, I want you to do the next 2 questions real quick and see if each of these do equal out. Do 5 to the negative 3rd, and then 1 over 5 to the 3rd. Do 7 to the negative 5th, and 1 over 7 to the 5th. And see if you still get the same exact thing. And then we'll talk about the rest of this property. So pause the video and answer those 2 questions. Okay, so did you come up with the same thing? Okay, so I'm going to pull up this calculator this time. I'm going to do 5 exponent negative 3. I end up with 0.008. And then if I do 1 over 1 divided by 5 caret 3, I end up with exactly the same thing. So I do end up with the same answers, 0.008 and 0.008. Okay, if you did 7 to the 5th power, the same kind of thing, 7 caret negative 5. Ended up with, oh my goodness, a big long ugly answer. Well, I need to remember this negative 5, all it means is I'm going to move this decimal 5 places. Okay, so that means I've got 4 zeros in front of that 5. 0.0000594 and so on. Okay, and you should have come up with the same answer on both sides. So what you find out is that this negative, what it's really going to do, a negative exponent flips the base and the positive version of the exponent to the denominator. Okay, so if I had it the other direction, okay, and we'll see this on the next slide, well, what if that negative exponent's on the bottom? Well, if this negative is flipping things, if this one over here is going to flip the numerator, all this information from the numerator down to the denominator, this one that's in the denominator is going to flip it up to the numerator. So if we look at the other half of this, okay, so here we've got 1 over 6 to the negative 4th, and if we were to type that one into the calculator, 1 divided by 6 to the negative 4, okay, we end up with 1296. We end up with a nice, pretty answer. Okay, so 1296. And if you were to type in 6 to the 4th power, you would end up with the same thing. Okay, so this negative exponent, what it's doing, if a to the negative n, the negative exponent is in the numerator, it's going to flip the whole thing to the denominator and make the exponent property positive. Okay, if the negative is in the denominator, like this one right here, it's going to flip it to the numerator and be positive in the numerator. So this is the toughest one to understand. Okay, so all the rest of them are pretty easy, but this one right here, we have to understand that this negative exponent, whether the negative exponent was originally in the numerator or the negative exponent is in the denominator, it's going to flip it. Okay, if it's in the numerator, then it's going to flip it to the denominator and the exponent will become positive. If it's in the denominator, it's going to flip it to the numerator and then the exponent will become positive. Okay, so like I said, excuse me, like I said, this is the toughest exponent property to understand. Okay, so let's move on. Okay, so here's our next property. What happens if I have a base and I raise it to the exponent of 3 here and I raise it to the exponent of 4 here? Okay, so if I were to type this into the calculator, okay, so now I'm going to go to the class calc one this time, okay, and it says I'm going to do 2 to the 3rd power, okay, and then I just hit that to move on, just like we do with our calculator, and I do times 2 to the 4th power, so that's my problem. If you look back at here, you got 2 to the 3rd power times 2 to the 4th power. This problem looks exactly the same thing. I hit enter and I get 128. Right? 128 with that. Okay, so let me go back here and let me write this down. 128. So now what we're doing on this particular problem is I want you to write me a 1 exponent expression for it. So if we really look at what this 2 to the 3rd power and this 2 to the 4th power really means, 2 to the 3rd power really means 2 times 2 times 2. And then there's a times in the middle, and 2 to the 4th power means 2 times 2 times 2 times 2. So if I want you to write me a 1 exponent expression, how would I write this expression right here down using that base? What would my exponent be? Well, if you'll notice here, how many 2's are there? There are 7 2's. So my 1 exponent expression would be 2 to the 7th power. Right? So if we were to look at this next one right here, 3 to the 2nd times 3 to the 6th, okay, what would my 1 exponent expression be? Well, if you'll notice here, in this first one we did 2 to the 3rd and 2 to the 4th. 3 and 4, what did I do to get 7? I added the exponents together. So this one right here, if I wanted to write a 1 exponent expression, it would be 3. I keep the base, and I take my exponents and I add them together. For these next two right here, what I'd like for you to do is write for me the 1 exponent expression, and then we'll talk about the conclusion. Okay, so let's see what you did. So in this next one here, we started with the 7. Now this 5 and this -3, if I were to add those together, what would I get? I would get 2. And if you actually do the evaluation of this one, you do actually get 49 as my evaluation, which is what 7 to the 2nd power is. Okay, now 8 to the 2nd times 8 to the 1st. Okay, well, 8 to the 2nd, there's 2 of them there, there's 1 of them here, so that's going to be 8 to the 3rd. Now the reason why I focused on the 1 exponent expression is because that's what you're going to be doing on your assignment for me today, is you're going to be writing a 1 exponent expression for each statement that we have. Okay, so whatever the problem is, you're going to take it and you're going to write it as a positive 1 exponent expression. In other words, no matter what, I need my exponent to be positive. Okay, so let's say what if this first problem right here, I had a -3 and I had a -4 on it. Okay, then when I add that together, what would I end up with? I'd end up with 2 to the -7th. Well, because we have to write our answers as a positive 1 exponent expression, what did we just get through saying this negative is going to do? If it's in the numerator, it's going to flip it to the denominator and be positive. Okay, so this would be my positive 1 exponent expression that I'm looking for. Okay, so just kind of keep that in mind. So let's try to do another one. Let's say, what if this 2 were positive, but this 6 here were negative? What if I wanted to do that one? Well, this one right here, then I'm going to keep my base. It's going to be a 3. I'm going to add my exponents together. 2 and -6 would give me a -4. But if I've got to write this as a positive 1 exponent expression, this is in the numerator, so it's going to flip it to the denominator and be positive in the denominator. Okay, so that's kind of a difficult thing to understand, but that's what I'm looking for on the assignment today. So let's finish talking about this particular one right here. Okay, so in this particular conclusion, if my bases are alike, what am I going to do with my exponents? I'm going to add them together. So it says keep the base and multiply, and actually you're supposed to add your exponents. Sorry, I don't know what happened there. And add, and add your exponents. Add your exponents. I must not have been thinking when I was typing that out. Okay, so you keep your base and you add your exponents together. Okay, now what if we have a division problem like this? Okay, well, same kind of thing. If I were to type this one into the calculator, 2 to the 4th times 2 to the, or divided by 2 to the 3rd, okay, and I evaluate that, what you're going to actually get is 2. Okay, Now again, let's kind of look at what this means. Well, 2 to the 4th power means 2 times 2 times 2 times 2 divided by 2 times 2 times 2. Well, if you remember correctly, okay, over the last several years, you found out that in fractions, if I've got the same number on top and the same number on bottom, they actually divide out and become a 1. Oops, I hit the wrong 2 there. Okay, so this 2 and this 2 will cancel out, this 2 and this 2 will cancel out, this 2 and this 2 will cancel out, and what's left behind are 1s. So they don't actually just disappear, they just divide out into 1. So now if I were to take my top numbers and multiply them together, 1 times 1 times 1 times 2, I get 2, and 1 times 1 times 1 is 1, so 2 divided by 1 is 2. Okay? So what would my one exponent expression be for a 2? 2 to the 1st power. Okay? Now what about this one right here? Okay, so I got 3 to the 7th, so that's going to be 3, 3, 3, 3, 3, 3, 3, divided by 3 to the 4th. And all those 3's right there, so these 3's right here divide out, divide out, divide out, divide out. And what am I left with? 3 times 3 times 3, which is 27. Okay? So my one exponent expression, okay, well, where are my 3's left at? My 3's are left on the top, so I end up with 3 to the 3rd power. So what am I doing with this 7 and this 4 in order to get a 3 as my exponent? We're subtracting them. Okay, so and this one right here, now this one's going to be tough. Okay, so basically what we're doing then is we're taking our bases, we keep our base, and we subtract our exponents. Top number divided minus the bottom number. Okay, so in this one right here, we got 6 to the 2nd divided by 6 to the 3rd. So we got 6 times 6 divided by 6 times 6 times 6. Okay, so those cancel out. These cancel out here, and I'm left with the 6 on the bottom. So if I were to multiply this together, I get 1 times 1 is 1, divided by 1 times 1 times 6 is 6. Okay? So this becomes 1 over 6 to the 1st power. Now how did I get that? Well, if you look at this right here, what we were just talking about, you subtract your exponents. So this is, we keep our base, we subtract our exponents. 2 take away 3 is negative 1. Well, what have I talked about? What did I talk about on the previous page? You can't leave an exponent expression negative. So since this negative 1 is like in the numerator, what happens to it? This negative is going to flip it down to the bottom to become 6 to the 1st power. Now, this one right here, we're going to keep our base, and I just said we're going to subtract our exponents. So this is negative 2 minus negative 3. So what happens with that? Well, I change my subtraction to addition next to its opposite, and this becomes 9 to the 1st power, or just 9. Okay? So what happens when we have a division problem? Okay? Well, this is what happens. This is our rule for division. Okay, we're going to keep the base and subtract the exponents. So sometimes when you do this, your exponent will end up negative. So that means you've got to use property 4 in order to get rid of the negative. Okay, and that was that negative thing that I've been talking about. Okay, we got 2 more properties to go and then we're done. I told you this was going to be a long video. Okay, so what if I have an exponent raised to an exponent? Well, this 3 to the 5th squared, what that really means is 3 to the 5th power times 3 to the 5th power. So based on that, if we look back at what we did with the multiply part, what did we do with our exponents when we multiplied? We added them together. So this would be 3 to the 5th and 3 to the 5th, which actually gives me 3 to the 10th power if we actually write the one exponent expression. Now I'm going to assume you can do the evaluation. We're going to focus on the one exponent expression for the rest of this. So what did I do to this 5 and this 2 to get 10? Well, we multiplied them together. Okay, so what about this one? This one means 2 to the 4th 3 times. So 2 to the 4th times 2 to the 4th times 2 to the 4th. What do I end up with? 2 to the, how many? 4, 4, and 4 is 12. So what do we do with our exponents? We just multiply them together. Okay, so if I have an exponent raised to an exponent, we multiply the exponents together. Keep the base, multiply the exponents. But what if one of those is negative? Well, so I multiply those together, so I end up with 10 to the negative 5. Now what do we have to remember about this negative 5? Well, this negative if it's in the numerator, it's going to flip to the denominator. So my one exponent expression then would be 1 over 10 to the 5th power. Okay? Now what if we have to the 0th power? Okay, well, if I multiply 3 times 0, I get 22 to the 0th power. So that would be my one exponent expression. But then what would my evaluation be? Well, we remember from the second property that anything to the 0th power would be 1. Okay, so what happens if I have an exponent to an exponent? You keep your base and you multiply your exponents. Now the last property we're going to talk about, property 8, is what if my exponents are the same but my bases are different? Okay, so this one right here, what this really means is 3 times 3 times 4 times 4. Okay, so if I were to take this 3 and this 4 together, I'd get 12. And if I were to take this 3 and the 4 together, I'd get 12. And 12 times 12 gives me 144 for an evaluation. But now how would I write that as a one exponent expression? Well, 12 to the 2nd power. My computer's fritzing again. 12 to the 2nd power. So with that in mind, what did I do over here in order to get 12 to the 2nd power? Well, we just take our bases and we multiply them together. 3 times 4 is 12, and we keep our exponent. So what would happen in this one? I would take the 2 and the 5, I'd multiply those together, and I would keep the keep the exponent. So that would be 10 to the 3rd power. So what about 7 to the 4th and 8 to the 4th? Good. 7 times 8 is 56. And I would keep the 4. Now what happens if I end up with negative exponents? Well, I'd still multiply my 5 and the 4 together to get 20, and that would be 20 to the negative 2nd. Now based on property number 4, I believe, okay, this negative exponent, what's going to happen to it? It's going to flip to the bottom and become positive at the bottom. So that would be 1 over 20 to the 2nd power. So what happens in a situation like this? You keep your exponent and you multiply your bases. Now that is all 8 of our properties that we've talked about today. Okay, we've talked about a to the nth, a to the 0th, a to the 1st. What happens if we have a negative exponent, whether it be on the top or on the bottom? Okay, whether it be on the top or on the bottom. What happens if my bases are alike and my exponents are different? Okay, and it's a multiply problem. Well, in this one right here, we add our exponents together. In property 6, we subtract our exponents. In property 7, we multiply our exponents. And in property 8, we keep our exponent and we multiply our bases. So what I'd like for you to do on your assignment today is something very simple. Okay, it's just a matching activity. Okay, so basically I've given you a problem, and I want you to match it to its positive one exponent expression over on this side. Okay, so there is a Google form for this that you can fill out, and all you're going to do on the Google form is you're going to put the letter of your answer choice for this. Okay, so this is lesson number 2 over exponent properties. You may have to watch this lesson a couple times or kind of scroll through it. I'm going to be posting the notes as well with this so that you can have that so you can kind of understand what it is that you're doing with exponent properties. Okay, so until next time.